So this is a question from the trig handout, and we want to maximize the area of the trapezoid on the end of a trough. So this is similar to another question I think that was in the lesson, but that one was not using the angle. That one gave an angle and asked how much should fold up on either end. And I'm just reading this question more carefully, and it says that, so you have a 20 centimeter fold on 3 parts here. Now, here, we're folding this up from 90, and this is 20 centimeters, 20 centimeters, and 20 centimeters. I forget which way they labeled this angle, but I'm just going to put my theta in there. It's possible that the correct answer is that outside angle, but I trust you guys can subtract from 2 pi, whatever our, or from pi over 2, whatever we end up getting. So remember that the area of a trapezoid is that, if that's A on top and B on the bottom, and the height goes down perpendicular, the area is 1/2 A plus B times H. So this is what we want to maximize, because however long the trough is, the amount of water it can hold is related to the area of this end times the length, and the length is going to be standard anyway. So we want to maximize the area here that this can hold. So what we need is our A and our B and our H into this equation. So we're going to need, we know that this would be 20, same as on the bottom. I'm going to label that with an X and this with an H for the height. And I want to find X and H in terms of theta. So I know here that cos theta is H over 20. So H is equal to 20 cos theta. And then the X, that sine theta is X over 20. So X is equal to 20 sine theta. Now, my A then would be 20, and my B, or vice versa, I suppose, would be 20 plus X, which is 20 sine theta, plus you'd have another X on the other side. So here I'm going to have 1/2 times, so 20 plus 20 sine theta plus 20 sine theta times the height, which is going to be a little too squished in here, 20 cos theta. So simplifying here, I've got 1/2 times 20 cos theta, which is my height, times here 40 plus 40 sine theta. So 10 cos theta times 40 plus 40 sine theta. So then I get 400 cos theta plus 400 sine theta cos theta. And that's going to be what I want to use to find the maximum area. That's an expression for the area of the trapezoid in terms of that angle theta. If we know those 20, 20, and 20 measurements for the shorter base and the 2 diagonal lengths. So from here, I'm going to take this and do the derivative. So 400 cos theta plus 400 sine theta cos theta. So if we want to find a prime at theta, so the derivative of the area in terms of theta, this would be negative 400 sine theta. And then in the second part, I have a product rule. So I'm going to lump the 400 sine theta and then the cos theta and then do product rule with those. So I get the first 400 sine theta times the derivative of the second, negative sine theta, plus the second, which is cos theta, times the derivative of the first, which is 400 cos theta. So now I get negative 400 sine theta and then minus 400 sine squared theta plus 400 cos squared theta. Now I definitely don't want to have a sine and a sine squared and a cos squared. So I'm going to substitute in here to get rid of that cos squared because the other two are in terms of sine. So I'm just going to sub in 1 minus sine squared theta, and we'll see what happens here. So I get negative 400 sine theta minus 400 sine squared theta plus 400 minus 400 sine squared theta. So negative 800 sine squared theta minus 400 sine theta plus 400, common factoring out a negative 400, so then I get 2 sine squared theta minus sine theta plus 1. And I think that this will factor minus 400, so I get 2 sine theta and then 2 sine theta, and that's minus 1 and plus 1. And I'm missing something. Oh yeah, this was a minus. When I factor out the negative 400, that would leave me a negative there, whoops, and a positive there. So I mixed up my signs here when I was factoring. But just to kind of double check, so I have negative 800 minus 400, so that would be negative 400 out front. And I will have positive 2, positive 1 there, and a negative 1 there. So double checking my factoring, I'm going to actually want plus 1 there and a minus 1 there. So if a prime at theta equals 0, we would want sine theta, missed my theta there, to equal negative 1, or sine theta to equal 1/2. Now, if we go back and take a look at our original picture, we need to define where theta could be. Reasonably, we definitely don't want to fold this in past like a 90-degree angle, and flat would be a terrible idea, but I guess you could. So I'm going to say that theta is in the range of 0 to pi over 2. So that would be my interval that would be applicable for theta. So if we were looking for sine theta equaling negative 1, then that would have sine theta equal 3 pi over 2. So that's inadmissible. If we wanted sine theta to equal 1/2, that would be theta equals pi over 6. That's a 30-degree angle. Pi over 6 for my theta, which does end up being the best choice. So we could figure out what's the area if theta was 0, and that would be kind of like looking at the shape of this. I don't even really have to do any math for this. I would know that that's 20 and that's 20. And if this angle in here was 0, it would be straight up at a 90 degrees. So the area would be 20 times 20, which is 400 centimeters squared. The area at pi over 6, using the calculator here. So we would have 400 times cos theta, which would be root 3 over 2, plus 400 times sine theta, which we know is a half, and cos theta, which is root 3 over 2. So this ends up being about 519.6 centimeters squared. And we would know that the area, if we went to our very outside limit of pi over 2, that area would be 0 because the height now would be 0. So this is the max area if you have that angle as pi over 6. Now it may give the answer as pi over 3. I don't remember. If it does, then they have measured theta as how much you're folding it up by out there, and we've solved for that theta. So it just kind of depends on that would be pi over 3, depending which one you were solving for and how you labeled it. Just flipping through here. This is a good one, page 147, number 20. If we want to find the minimum distance from this point to a point on my curve. So if we have this point, P1, that's negative 3, 3. And hopefully we're okay if we say that P2 would be x and x minus 3 squared. So the y value on that parabola would be x minus 3 squared. And the distance is from grade 10, x2 minus x1 squared plus y2 minus y1 squared. So I'm going to rewrite this. I feel like I'm going to have an easier time if I call this x and then x squared minus 6x plus 9. I just feel like that's likely to be a little bit easier. So this is going to be my, got some colors going here. That's going to be my x1, y1. And this is going to be my x2, y2, and we want to minimize that distance if I put that all together. So d is the square root. This is going to be x minus negative 3, so plus 3 squared, plus x squared minus 6x plus 9 minus 3 squared. So simplifying, we've got x squared plus 6x plus 9, and then this is x squared minus 6x plus 6, all squared. I don't know if I'm doing myself any favors here foiling this out, but we will. Because I don't necessarily want product rule inside my chain rule that I'm going to have. So this is going to be x squared x to the 4th minus 6x cubed plus 6x squared minus 6x cubed plus 36x squared plus 6x squared minus 36x plus 36. Lots of 6's in there. So we get x to the 4th. How many x cubes? Minus 12x cubed. And then, how many x's? 6, 42, 48 x squareds. I feel like I've messed something up here. X to the fourth minus 6x cubed plus 6x squared, and then we've got minus 6x cubed plus 36x squared. Oh, I missed minus 36x up there. So yes, then I have, looking at my x squareds, I think I was at plus 48x squared, and then minus 72x plus 36. So then I'm going to add on, and just to kind of simplify my life here, adding on the x squared plus 6x plus 9 from up there, that I'm going to end up getting x to the fourth minus 12x cubed. Now I would have plus 49x squared, and then minus, what will that be, 66x, and plus 45, all to the exponent 1/2. So then when we do the derivative, d prime at x, we get 1/2 times this whole bracket to the exponent negative 1/2. I know that that's going to go on the bottom. It's not going to be what ends up getting me my zeros here. So I would have 4x cubed minus 36x squared for the derivative of this plus 98x minus 66. And that looks like a mess to factor, but that's kind of the process that we would take. And I'm going to have to kind of grab a calculator or Desmos that to figure out what the zeros are.